Uranus is warmer than we thought. NASA and Oxford's surprising discovery. You might think you know the story of Uranus, the icy, sideways planet that defies every rule in the solar system's playbook. But here's where it gets controversial. Scientists just turned the script upside down. What if the planet we once called the cold king of the ice giants is actually hiding a secret warmth beneath its frosty exterior? Let's dive into how decades of data, a dash of computer magic, and a few stubborn questions are rewriting our understanding of this mysterious world. For starters, Jupiter, Saturn, and Neptune are like cosmic furnaces. They emit more energy than they receive from the sun, which means their cores are still glowing from the heat of their birth 4.5 billion years ago. But Uranus? It was long thought to be the odd one out. Back in 1986, NASA's Voyager 2 mission zipped past the planet and found it colder than anyone expected. So cold, in fact, that scientists scratched their heads and wondered if Uranus had somehow lost all its internal heat. Could it be a relic from an ancient collision? A planet so old it's gone cold? No one could say for sure. And this is the part most people miss. The answer might have been hiding in plain sight. A team led by NASA's Amy Simon and Oxford's Patrick Irwin took a fresh look at the data, along with a powerful new computer model, and found something surprising. Uranus isn't just a frozen rock after all. It emits about 15% more energy than it gets from the sun. That's not as much as Neptune, which is practically a heat-spewing giant, but it's enough to rewrite the textbooks. We thought there was no internal heat at Uranus, says Irwin. But when we crunched the numbers, we realized it's actually more reflective than we gave it credit for. How did they figure this out? By building a model that acts like a cosmic calculator. The team simulated how Uranus reflects sunlight at every angle, front, back, sides, and compared it to the heat it emits. Think of it as shining a flashlight on the planet and measuring how much light bounces back versus how much escapes as warmth. Their results, published in the Royal Astronomical Society's journal, show Uranus isn't a heatless ghost. It's just a quiet one. But here's the twist. This discovery raises even bigger questions. If Uranus has internal heat, what does that mean for how it formed? Could it be younger than we thought? Or maybe its tilted rotation and unique climate are hiding clues about its past. And what about exoplanets? Those distant worlds we're just starting to study. Many of them are Uranus-sized, and this new research could help us decode their mysteries too. So what do you think? Is Uranus just a cosmic underdog, or is there something even stranger going on? Drop your thoughts in the comments, because when it comes to the universe, the weirdest stories are often the truest ones. Uranus surprisingly warm. New insights revive planetary mission hopes. Uranus, the enigmatic planet, has revealed a surprising secret that could rewrite our understanding of its origins and evolution. The revelation? Uranus is warmer than we thought, and this internal heat might just be the key to unlocking its mysteries. ****. Scientists, led by Xingyue Yang from the University of Houston, have discovered that Uranus emits more heat internally than it receives from the sun. This finding contradicts previous observations made by NASA's Voyager 2 probe in the 1980s. By analyzing decades of data and employing computer models, the researchers found that Uranus' internal heat is approximately 12.5% higher than the heat it receives from the sun. While this is still less than the internal heat of other outer planets like Jupiter, Saturn, and Neptune, it's a significant discovery. But here's where it gets controversial. The researchers suggest that this internal heat could indicate a unique internal structure or a different evolutionary path for Uranus. They believe that Uranus, which formed around 4.5 billion years ago, might have started closer to the Sun and then migrated to the outer solar system later. This theory challenges the conventional understanding of Uranus formation and development. And this is the part most people miss. The internal heat of Uranus could provide valuable insights into the planet's early history and how it has evolved over time. As Wang stated, this means it's still slowly losing leftover heat from its early history, a key piece of the puzzle. The iconic Voyager 2 probe's flyby of Uranus in 1986 provided much of what we know about this distant planet. However, it seems we might have caught Uranus at an unusual time, and some of the probe's readings could have been influenced by solar weather activity during its visit. By reviewing archival data and combining it with computer models, researchers now believe that Uranus' internal heat could lead to a complete rethink of our understanding of this planet. This new perspective on Uranus' internal processes could also aid NASA and other space agencies in planning future missions to this mysterious world. The National Academy of Sciences has already flagged a mission concept known as Uranus Orbiter and Probe, UOP, as a top priority for planetary science in the next decade. However, with budget uncertainties and political challenges, the road to making this mission a reality is far from easy. Whether or not this new research gains support for such a mission, scientists are already praising these findings as groundbreaking. Study co-author Limingly believes that understanding Uranus' internal heat not only enhances our knowledge of this distant, icy world, but also provides insights into similar processes on Earth, including our changing climate. By uncovering how Uranus stores and loses heat, we gain a broader perspective on Earth's atmospheric system and the challenges of climate change, Lee said. A study on Uranus' internal heat was published in the journal Geophysical Research Letters, offering a fascinating glimpse into the mysteries of this unique planet. What do you think? Could this new understanding of Uranus' internal heat influence future space exploration missions? Share your thoughts and join the discussion. Uranus' hidden heat. New discoveries challenge previous theories. Imagine a world so strange and distant that it defies our understanding of how planets behave. Uranus might just be warmer than we ever imagined. This revelation comes from two groundbreaking studies published in prestigious journals, the monthly notices of the Royal Astronomical Society and Geophysical Research Letters. But here's where it gets intriguing. Uranus, with its peculiar sideways spin and backward rotation, has long puzzled scientists by appearing to lack any internal heat. However, new research suggests otherwise. Uranus, unique among the planets in our solar system, rotates on its side, meaning each pole experiences a 42-year-long summer. Additionally, it's the only planet besides Venus that rotates in the opposite direction. When NASA's Voyager 2 spacecraft flew by Uranus in 1986, it recorded data indicating that the planet was unusually cold internally. This finding challenged existing theories about planetary formation and evolution. Dr. Amy Simon, a planetary scientist at NASA's Goddard Space Flight Center and co-author of one of the studies, highlighted the puzzle. Since Voyager 2's flyby, everyone believed Uranus had no internal heat. But explaining why has been difficult, especially when compared to other giant planets. The initial conclusion was based solely on Voyager 2's single measurement, which made it a critical piece of data, but also a potential source of error. To address this, Dr. Simon and her team used advanced computer modeling and reevaluated decades of data. Their findings suggest that Uranus does indeed generate some internal heat. A planet's internal heat is typically calculated by comparing the energy it receives from the Sun to the energy it emits into space as reflected light and heat. In contrast to Uranus, Saturn, Jupiter, and Neptune all emit more heat than they receive, indicating that this excess originates from within. The amount of heat a planet emits can provide clues about its age. The less heat emitted relative to absorbed solar energy, the older the planet. Uranus stood out because it seemed to emit as much heat as it received, suggesting it had no internal heat source. This discrepancy led to various hypotheses, such as Uranus being older than its siblings or having experienced a massive collision that expelled its heat. However, none of these theories fully explain the observations. Professor Patrick Irwin from the University of Oxford, lead author of one of the studies, expressed skepticism. Could it really be that there is no internal heat at Uranus? To answer this, the researchers recalculated how much sunlight Uranus reflects, discovering it to be more reflective than previously thought. Their approach involved developing a comprehensive computer model that integrated all available data about Uranus' atmosphere, including information from ground-based telescopes and space missions, like the Hubble Space Telescope and NASA's Infrared Telescope facility. This model accounted for the planet's hazes, clouds, and seasonal variations, all of which influence how sunlight is reflected and heat is emitted. The results showed that Uranus emits approximately 15% more energy than it receives from the Sun, aligning with estimates from a second study. While this internal heat is present, it remains significantly lower than that of neighboring Neptune, which emits more than twice the energy it receives. The discovery raises new questions about Uranus' internal dynamics and challenges our current understanding of planetary science. Dr. Simon emphasized the need for further research. We now need to understand what this residual heat means and obtain more precise measurements. These findings not only shed light on Uranus, but also prompt us to reconsider the fundamental principles governing planetary behavior in our solar system. References: Patrick G. J. Irwin et al. 2025. The Bolometric Bond Albedo and Energy Balance of Uranus. MRAS 540, 2/1719-1729. doi 10.1093/MRAS/staff800. Xinhua Wang et al. 2025. Internal Heat Flux and Energy Imbalance of Uranus. Geophysical Research Letters 52, 14 E 2025 GL115660. doi 10.1029/2025 GL115660.